This video provides short introduction to data science using Python. What is data science? Data science is the process of collecting, analyzing, and interpreting data using statistical and machine learning techniques to discover patterns and make predictions. So, consider data which is student's database containing name of the student, study hours, and mark on 100 system, 100 maximum mark. So let us load this data into Colab notebook, which is useful environment for quick start with data analysis. First of all, we have to import pandas library, which is collection of useful tools for working with tables and structured as well as unstructured data. So we are loading pandas library. Then we have to read our file, which is called students CSV, and put it into some variable, for example, data. Okay, we can have a preview of our data. So data at the first 5 records are shown here. Okay, so let us extract the study hours and marks into separate variables. For example, to variable x, we place data, let it be study hours, and to variable y, we put data mark. Okay, there is useful prompting here. Okay, so let us try to view this data shortly. Yes, these are marks, array of marks. Yes, and this is array of study hours. Let us try to plot it to have visual information on how preliminary study hours are connected with marks. For this purpose, we need a graphical library, import pyplot, matplotlib. We use matplotlib and sublibrary pyplot. We denote as plt. Okay, so now we can use it. Plt plot x, y, and by points x and y. Okay, this is a cloud of on the x values. On the x-axis is the other study hours, and marks are on y-axis. So we can, by the way, make labels. LT X label, we will call it study hours. And correspondingly, the axis of coordinates as mark. Okay, so from this mutual distribution of study hours and marks, we can make preliminary conclusion about some correlation between this data. But this we will show in more detail a little later. Now let us try to show some basic operations which we can make with this data. We can extract various, for example, statistical characteristics of our arrays x or y. For example, we can calculate the maximum value of array X. So maximum study hours is 9.4. Minimum value correspondingly is 0.4. So just 24 minutes. It's interesting to observe what mark did receive this person. Okay, mean value is 4.23. Okay, and mean value of obtained mark is 68.2. Okay, let's try also to visualize the distribution of marks using the histogram. For this purpose, we will need the hist function using, for example, for array y using marks, and how many we have to define how many beans will we use. Beans, for example, 20 beans. Okay, let us see what we will get. Okay, this is the histogram, which shows something like quite a Gaussian distribution. Okay, also we will plot here the mean value on this graph in the following form: PLT X V line mean value. Let us put a mean value into separate variables. Let us call it M. It would be y mean. Okay. So this line should contain M. Okay. And color, let it be red. Okay. Let's see what happens. Okay. Here our mean value is depicted. Also, let us make it dash. Yes. Line style. Let me see the exact name of the command. Yes, it's line style. Exactly. Line style. Let it be dash. Okay. Something like this. And label. Let us put also label here. This is mean value. Okay. This mean value is not yet depicted because at the end we should activate all the legends. Legend, I think this. Oh, not plot, but PLT. Yes. Okay. Mean value. Okay. Let us also show 3 sigma bounds, which are well-known characteristics from statistics. So it is known that for distribution which is almost normal, almost Gaussian, the most of the values are contained within the range of 3 sigma, where sigma is the standard deviation. Let us calculate standard deviation for array y. Okay, let us print its value. Let's say print sigma. Yes, sigma is 9.9.8. Okay. So this means that all marks are distributed in average, mean squared average error in almost 8.9 from its mean value. Okay, let us also add mean value minus 3 sigma. Let's make it in black color. Mean minus 3 sigma. And in the same way, to the positive side, m plus 3. Let's make it in, for example, okay, let's also be black. Mean plus 3 sigma. Okay, so yes, the general statistical rule is confirmed. We see that almost all of the values of our marks lie really within the range of plus minus 3 sigma relative to the mean value of mark. So any values which are generally outside the 3 sigma region are suspicious to be outliers. But in this case, we almost have no outliers, so our data is quite well defined. Well, we will consider what to do with outliers in one of our next videos. Okay, so in this way we build the histogram. Now we will try to predict the values y based on x. For this purpose, we will use the tool which is called linear regression. We would need some useful functions from sklearn library, doing in this case with linear regression. So we load a special library which is called linear regression, and we make fitting or calculation of regression coefficients for predicting of values y based on x. Yes, we have an error because x and y are now just like a data arrays. Yes, they have to be converted into numerical values. For this purpose, we can use NumPy library, import NumPy SNP. Okay, now we should convert x as NP array x and correspondingly y. Before calculating linear regression, let's see how these arrays now look like. So this is x, okay, NumPy array, and this is y. Okay, are we ready for passing them into the linear regression? Well, not really, because we have to reshape the data before passing them onto linear regression function. Let's see what does it mean. Now the shape, or let us say the size of array x is it's not array yet, it's more like a numerical list. So it has only one dimension. Yes, and the same with y. Has only one dimension, but they should be presented as two-dimensional arrays, even though they will be just like one column. So we have to reshape both x and y. X, let us proceed directly with the squeeze method, which will squeeze, yes. Let's see. Okay. What is now the shape of x? No, didn't. Okay, let us then use simple reshape. Reshape -1. Okay, yes. Now X is an array of, it's a column. It's a column, and let us column of one-dimensional. It's one-dimensional array. It's just like a column, and Y is the same in the same way. Yes. Now it has shape 1000 per 1. Okay. Can we now calculate the coefficients of linear regression? Yes. Let's see what have we calculated. From the theory, we know that linear regression object, it returns basically two parameters. It's the weight and intercept. Two parameters, first of which is like a slope of a line, which predicts values of y based on x. So let us see what this slope coefficient or weight coefficient is. 5.7. And the free term, which is called also intercept, is 43.47. Okay, let us now return to the plot of our data. So we had a plot of x and y. And now we will also add here the plot of linear prediction of y based on x. Let us denote as w the weight coefficient, slope, and as b the intercept. So we will see how well can we predict x by y from x values. So it will be wx plus b. Okay, so we see a line which approximates the values of y, which are the marks of the students based on x, the study hours. So we can see that its prediction is now performed quite well, at least in mean square sense. And for example, if now I know that some student dedicated, let us say, 3.5 hours for his study, we can predict now easily his mark by multiplying the study hours on weight and then adding parameter b. So his predicted mark will be 64. Of course, if we increase the study hours, the resulting mark increases. And in fact, finally, it can even reach values higher than 100, theoretically. But in this case, of course, we should implement some limiting function. Okay, this was a short introduction to data science procedures using Python. We considered how to load data into our Colab notebook, how to calculate basic statistical characteristics, how to build spectrogram to check 3 sigma rule for normal distribution, and also considered making linear predictions of one variable based on the values of another. Thank you very much for your kind attention.